Hi, this is Dr. Bitla Venu coming in front of you with a topic called CNC Part Programming. In the last session, we have discussed introduction to CNC Part Programming, in which we have seen the different steps. What are the steps required to write a part program? We have seen. Then we are also discussed the importance of part program, advantages, disadvantages of the part CNC Part Program. We are discussed in the last session. Then in the last session, we are also discussed the types of part programs. So how many ways we can write a part program? There are two different ways. One is manual part programming and other one is computer assisted part programming. Manually we can write, and as well as we can also take the help of a computer. Then we are calling that as a computer assisted part program. These two we are discussed in our last session. Then in this session we in the last session we are also discussed the part programming languages, different types of part programming languages. We are also discussed APT type, automatically programmed tools, compact and extended version of APT. We have seen the different types, but out of all these computer uh, part programming languages, CNC part programming languages, APT is normally used and widely used in the industries, widely used by the industries, because the program is more flexible to write, to instruct the NC machine. So this is what different types of part programs also we are discussed. Then in the last class, we are also discussed the coordinate system. In which we have discussed the milling and drilling machines, and as well as the turning machines, in which we have discussed that in what way the X, Y, Z axis, the coordinate axis system is oriented in the milling machine as well as the drilling machine. In what way table as well as the tool is oriented uh, to the axis. So that we are discussed. That along with the figures we are discussed in the last session. In the turning machine also we have seen in what way the axes are oriented along the tool bit and as well as the work table. That we are discussed in the last session. Then let me move further to discuss what are the contents in this session. This session includes the coordinates referencing methods. In what way we are referencing the coordinates, in which we are going to discuss the absolute positioning and the incremental positioning. While specifying the moments of the tool, in what way we are specifying. So in this case, we have two types. One is absolute and other one is incremental. We will see how we are referencing the coordinates. To reference the coordinates of the tool, or to reference the coordinates of any of the moments on the table, on the NC machine, there are two approaches. One is absolute and another one is incremental. We will discuss in detail with an example in this slideshow. Then we move forward to discuss fixed zero and floating zero. In what way we are referencing, that is one part, and the other part is, from which location we are referencing the coordinate. So, whether your origin is fixed at one location or whether it is movable to some extent, or it can be shifted to any location. That tells us about the fixed point zero and floating point zero. We will see these contents also in this session. In the next session, we will see the the next content is that ANSI part programming, in which we will see the structure. We will discuss structure, what exactly the structure of the ANSI part programming, and then we will discuss the standard functions or the codes required to write a part programming. We will see what exactly the structure and what exactly the words and codes required to write part program in this content. This is exactly the brief summary that we are going to discuss in this session. In the next slide, okay, in this slide we will discuss the coordinate referencing method. As I said just now, there are two approaches to reference the coordinate. One is absolute and other one is incremental. In any of the machine, in any of the NC machine, almost all the NC machines are going to use the Cartesian coordinate system. Cartesian coordinate system means in which X, Y, Z axes are taken as reference point, reference axis, and with respect to these axes only we are going to control the movements. We will provide the coordinates with respect to x, y, z axis only. That means we will provide the coordinates of x, y, z to control the movements of the tool, to control the movements of the table. This is what happens in the case of NC coordinates referencing methods. So basically this NC coordinate referencing methods uses the principal axis, those are x, y, z. With respect to using these axes only, we are going to provide the coordinate values. Okay. Then, as I said just now, there are two referencing methods. One is absolute and the other one is incremental positioning. In the case of absolute positioning, the locations are always defined about the 0 points. That means we have one origin point. With respect to that point only, all the coordinates, all the movements, all the reference points will be located. That means we have one standard fixed point at that location. With respect to R, instead of calling that as a fixed point, we have an origin. With respect to that point, with respect to that 0 point, we are making one 0 point as location on the machine. With respect to that, we will provide the values. That is called the absolute positioning. Means absolutely we are going to measure with respect to one point. That means all the coordinates, all the referencing points we are going to refer in the program will refers to that point only. With respect to one point, we will provide. Just like x, y, z, assume that we have one x-axis and z-axis, we have intersection, that is called origin. With respect to this point, we are going to provide all the values. And similarly, in this case also, we have one reference point or 0 point or absolute point. With respect to that absolute point, we will provide the locations, we will provide the reference coordinates to give the motions for the tool and to give the motions for the table. This is what the absolute positioning. So we have one fixed point. With respect to that point, absolute point, with respect to that point, all the locations are going to refer. This is called the absolute positioning. In the case of incremental positioning, so in the case of absolute positioning, the next location is not at all going to consider the previous location. That means the next point is not going to consider the previous point. Suppose you are referencing, you are provided 2 points, point 1 and point 2. So this point 2 is no way concerned with the point 1. The point 2 always refers, always having the values with respect to one point, that is called the reference point. That in turn you can call it as an origin point. So that is called the absolute point. But whereas in the case of incremental positioning, the next location of the tool or as well as the table is referenced with respect to the previous location. So previous location in the increments of the first point. So that we will see with an example in the next slide. Assume that you have an x-axis here and y-axis here. You can see the coordinate values also some extent in this case. Then as you have one location here, point 1. Its coordinates are 4, 5. The first point or the current location of this tool is at this location. Its coordinates are 4, 5. Then you have another location. If you want to specify this location, its coordinates are initially the coordinates are 4 and 5 and the final values are 6 and 8. Assume that. So this 6 and 8 refers to the absolute position. As you can see here, 6 and 8 are referring the origin point at this location. So this next location of the current location, this is your current location. Now you are at this location. If you want to provide one more location, that we are calling as next location. So if your next location coordinates are with respect to the origin, then it is called the absolute position. As I said just now, this location, that means the next location is not referencing, no way considered and no way concerned with the current location. Irrespective of this location, we are providing the next location. That is called the absolute positioning. So this next location is with respect to the origin, not with respect to the previous or the current location. Okay, so this is called the absolute position. As you can see, in the case of absolute positioning, the coordinates are x, 6. Now you come to the incremental positioning. In the case of incremental positioning, the next location will be with respect to the previous location or the current location. Now you are at this point. Assume that now we are at this location, current location. To specify the next location, we are going to refer the first location. So to specify the next location, we need to increment the current location like this. Suppose if the next location, if you want to specify 6, 8, the value should be x value is 2 and y value is 3. That means 4 plus 2 is 6 and 5 plus 3 is 8. That means if it is an incremental positioning, the coordinates of the next location will be 2, 3. If it is an absolute positioning, the coordinates of the next location will be 6, 8. So in this case, you can observe the next point in the case of absolute positioning is referencing the origin. With respect to origin, so the x coordinate value is 6 and y coordinate value is 8. If it is incremental positioning, you can see that these two values are not referring the origin. These two values are referring the previous or the current location here. Okay. In the current location, we have 4, 5. If you want to specify 6, 8, then you increase this value, x coordinate to 2 and y coordinate to 3. That means you will get the 6, 8 like absolute positioning. So in incremental positioning or in the incremental referencing method, the current location will be taken into account to specify the next location. In terms of increments, the current location will be increased, or we will give increments to the current location to specify the next location. In turn, you can call in that way, or you can specify in that way. The current location will be incremented to specify the next location in the case of incremental position. In the case of absolute positioning, the origin will be taken as the reference point. The current location will not be considered, and the next location is going to refer the 0 point or origin point. This is regarding the absolute versus incremental position. So in what way you are referring the coordinates in the case of part programming? You can refer the coordinates in two ways. One is absolute and other one is incremental. This we need to instruct the machine in what way we are providing the values, coordinate values for the movements of the table and for the movements of the tool. If you use incremental, the approach is different. If you use absolute, the approach is different, as I said just now. So let me move forward to discuss the other content, that is fixed 0 and floating 0. In the case of fixed 0, so origin is always located at same location or same position on the machine table. In the case of fixed, there are two terms in CNC Part Programming or referencing method: fixed 0 and floating 0 point. Fixed 0 point, fixed point 0, in turn you can also call fixed point 0 or fixed 0 point. The origin is fixed. That means, and throughout the programming, the origin is at that location. With respect to that point, all the locations, all the coordinate values in that program is going to refer that fixed point or fixed point 0. So with respect to that point, all will be considered. Normally, in any of the mission, bottom left corner or the southwest corner will be taken as a fixed 0 point. In almost all the, if you want to adopt the fixed 0 point system, bottom left corner means southwest corner will be taken as the fixed 0 point, and all the x and y coordinate values or all the coordinate values in that program will be positive, because we are already keeping the 0 point at bottom left corner. Whatever the values we are referring will be positive. So there is no negative values in the case of fixed 0 point. Sometimes this programming may not be flexible. Suppose this programming is used, this type of method is flexible for, not for the rotational comma. So suppose if you take a rectangular block. In the case of rectangular block, you can assume the bottom left corner as a reference point, then you can provide all the coordinate values to work on the work plane or the component work plane. So, and all those values are positive. That is flexible. But whereas in the case of turning, so we can take the axis of that component as the reference point, as the zero location. So with respect to the axis, the radius varies, the radius you can give, or the movement of the tool you can vary. This is what the difference between the requirement of the floating zero. Sometimes we need to assume that the reference point may be the axis, the your reference point may be the axis of the component. So clearly you can observe in the case of turning. So now you see here, in the case of floating point zero, the operator can set 0 points to any point on the machine table. Not only the axis, at any point you can shift the zero location. With respect to that zero location, the coordinates are going to be referred. Okay, so this is what, this is flexible in the case of turning operation. In the case of turning operation, the axis will be taken as the floating 0 point. With respect to the origin, the coordinate values will be are going to refer. So in the case of fixed point 0, the origin is always fixed. So preferably that is at the bottom left corner. In the case of floating point 0 or floating 0 point, the origin can be shifted conveniently as per the convenience of the programmer, as per the convenience of the machining table. At any point we can shift the origin point. That is called the floating point 0. So these are the differences between fixed point 0 and floating point 0. Then let me move further to discuss the NC part programming. In this case, NC part programming is made up of series of commands. Basically, NC part programming is nothing but the series of commands. So those commands will be given as input to machine control unit of CNC machine in serial manner. Means one command, after executing one command, the other needs to be executed. In the serial manner or the sequentially, we are going to instruct the machine to perform the task in an order. Okay, that is called the part programming. I mean, whatever the program what we are going to write, that must be able to instruct the machine tool to perform the object or to perform the operations sequentially. That means this program instructions must be sequential. So this will be having the commands. That means program is going to issue the command to the machine control unit. In turn, that machine control unit will instruct the machine tool to perform actual work. This is what the objective of the part programming. Okay, and this MCU part program consists all the commands grouped together. When we group the commands together, that is called the part program. So those commands are interpreted into the machine readable form. So the duty of the machine control unit is to receive all the input commands in the form of program, in the form of programming, and this MCU is going to interpret the commands into the machine readable form, or the our MCU is going to generate the signal. According to that signal, the machine is going to act. The actual work takes place on the machine tool according to the instructions received by MCU. That means MCU function is to interpret the program of commands which lies in the part program, and to generate the signal to perform actual work by NC machine tool. That is MCU duty. So then NC programming is, the program is required to have a particular structure, because we cannot issue the instructions randomly. It must have some structure, it must have some syntax or format. Suppose if you are writing some program, example you take C programming or any of the programming language, to write a program in multiplication table in C program. So it requires some syntax. To write a program in any of the language, there must be some syntax everybody needs to follow, and that syntax must be understood by the CNC machine. So that syntax is called structure. structure of the program. Okay, so that structure must be understood by the controller. Okay, MCU, machine control unit. In turn, that machine control unit converts the commands or the structure of the program into the machine readable form. So this structure should be understood by the machine control unit. In turn, machine control unit converts those commands in the program structure into the machine readable form. Then the machine tool is going to act according to the instructions. That means every program, CNC program, must have syntax. Not every program. CNC programs are written in a specified syntax, in a specific syntax, which is understood by the controller unit of the NC machine tool. Then these commands are inputs to the controller, as I said just now, in the units called the blocks or the statements. Okay, in turn we can call a program consists number of statements or the blocks which is specific to perform one task. So suppose if you are performing turning operation to reduce the diameter of a component. So using one block of statement, you can perform one operation. Okay, that means in turn you can call it as one command. So the command of the controller, I mean this command, one command means one instruction to the machine tool. So in turn you can call that as a block or one statement. So one block or one statement is going to perform one activity or one action in other terms you can call. So a program consists number of blocks which are going to perform number of actions on the machine tool. Number of statements or blocks. So one block or one statement is responsible to do one action on the machine. So if you combine or if we combine all the blocks or statements together to complete one component which consists number of operations, to complete one component which requires number of operations. So each operation will be performed by one block of statement. One block of statement is responsible for one action or the one operation on the machine tool. If we combine all these blocks or the statements, we can call that as a program, NC program. Okay. So we will discuss what is block and what it contains and what exactly the program in the next slide. So each block is made up of one or more machine commands, as I said just now. So each block consists number of commands. We will see what exactly. Group of commands given to NC machine tool to operate NC machine tool is called the program. So we are combined together. Number of commands are combined together to form one statement, one block, which is responsible for one action. If all those blocks are combined together, all those statements are combined together to form one program, in turn, which gives us the which is responsible to complete all the operations to be performed to get one component on the or to complete machining on the machine tool. So this consists of this. Normally, the program should consist of information related to the part geometry. We require the information related to the part geometry. Then the motion statements. That means the program consists the part geometry also. Then the motion statements. That means motion statements means with how much speed the spindle should rotate and whether to use coolant or not. All these are called the miscellaneous statements. Okay, so all these will be the motion statements. Then the cutting speed, feed, depth of cut, and all those will be incorporated while writing the part program. Part program consists of all these information: part geometry, motion statement, cutting speed. For every action, for every action of the machine or the which is to be performed on the machine. So we need to select the speed, feed, and depth. For example, you take feed needs to vary for turning operations. Turning consists the rough cut turning and the finish cut. During the rough cut turning, feed is different and depth of cut is different and speed is different. Whereas finish cut turning process, the speed, feed and depth of cut is different. So that means in the form of blocks or in the form of statements, we will instruct the machine tool to perform actual work. So this program consists of all this information. Then we have auxiliary functions like whether to use coolant or not, whether to rotate the spindle in clockwise direction or anti-clockwise direction, whether to start programming or stop programming. All those are called the auxiliary functions. In turn, we can call these functions as the miscellaneous functions. We will discuss in detail regarding these miscellaneous functions and the motion statements in the coming slides or in the coming session. Then let me move forward to discuss what exactly the structure of part program. Part programming, as I said just now, uh, consists the character. If we combine with the help of characters, we are going to form the word, and if we combine words together to form the block, which is responsible for one action. So one block of statement is responsible for one action, one operation on the machine tool. Then if we combine the number of blocks or the statements, so to get a program. So character gives us the word, words gives us blocks, blocks gives us the program. This is what the hierarchy to write a program. Using characters, we write the word. Using words, we write the block. Using blocks, we write the program. Now let us see what exactly the character is the smallest unit of CNC program. Yes, it is the smallest unit. It comes under bottom line of the program, each program. So it can give a digit, it can have a digit or a letter. Example, if you want to specify a machine to rotate with certain RPM, in that case we are going to use S letter, which specifically instruct the tool, which specifies the spindle speed followed by the number. So you have one character here, which signifies, which says that it is a spindle, which is the spindle rotation. So if this S is followed by one number, example S1000, that means S is a spindle speed. Always it is having some character. This S character says that the speed of the spindle that needs to be rotated. Then S followed by the number, so which gives us the numerical, which gives us the meaning to this S. So S followed by the number, if you take 1000, that means the spindle needs to rotate with 1000 RPM. Then F, you have one more term, one more character or one more code here. F is a feed function, S is a speed function, F followed by the number, F200. Assume that you have F200. We are instructed, we are used F200 in a word. Okay, so that word tells us 200. F200 means 200 mm per minute. That means the feed of the tool is 200 mm per minute. Per minute, the tool has to move 200 mm distance. That is the meaning of the feed. So F and S are the characters which signifies specific meaning to the word. Okay, so the characters are used to form the words. Okay, suppose F is followed by a number, that gives us some meaning, feed function otherwise. Okay, so that is called word. Then S is followed by a numerical, that is called the word. So S alone can have meaning. S alone cannot instruct anything. So to have meaning, to get meaning, so character must be mixed with the numerical value. Then only it will form a word and it is having some meaning. So let me move forward. What is word? So word is a combination of alphanumerical character. As I said just now, character cannot have meaning. Okay, if character is combined with the numerical value, it has some meaning. In turn, we are going to call that as word. So character and the numerical value is combined together to form the word of the ANSI. Okay, as I said just now, it is having identification letter and series of numerical. So this create a single instruction. Okay, this create a single instruction to the machine. Okay. So not exactly the instruction. So if all these words are combined together to get some meaningful command. Okay, example, you take F200. So F200 means F is a word. F200 is a word. It signifies, F signifies that F is a feed. That means the tool having a feed of 200 millimeters per minute. That means the tool is going to advance 200 distance in 1 minute. That is what the meaning of this word. So character alone can have any meaning. So if the character is combined with some numerical, then only it is having some meaning. Okay. So next, this represents the axis positions, feed rate, speed, preparatory commands, and the miscellaneous functions. We will see what exactly the preparatory commands are, the preparatory functions and miscellaneous functions in the coming slides. Then let me move further to discuss what exactly the block. Block may contain multiple words. If the words are combined together, the words are combined together to form a block, which signifies one command or one instruction to the machine to perform one operation, like that. So block may contain multiple words. Definitely it must contain the multiple words if we combine words to get the block. Sequenced in logical order of processing, and all these blocks are sequenced in logical order of processing. So that means if we have number of blocks, so the first block will be executed first, then the next block will be executed by the next. So in which order we are giving the blocks is also very, very important. So to perform the actual work on the machine tool, the first block will be executed first and the next followed block will be executed next. This is what happens. So the execution of the blocks takes place according to the order in which the blocks are arranged. That is very, very important. So the arrangement of blocks is very important to get the accurate work. Okay, so then you can observe one block here. Example, you take one block here, N20. N is one sequential number, so which signifies that the sequence of the block, always this will be the first word in any of the block. Any of the block should start with a sequential number. N indicates the sequential number. Then it is 20, means N20 signifies the address of this block in turn. Of course, this 20 is not going to tell us the execution order. It tells us only the address of this block. Okay, so N20 is the address or the sequence of the block. Then we have G function here. We will discuss what exactly G01, and you have X coordinate, so coordinate function here, then feed function here, speed function here, then you have one more function, M function here. In turn we can call it as a miscellaneous function here. We combine all these words. N20 is a word, G01 is a word, then the coordinate function, feed function, speed function, then we have M code or a miscellaneous function. If we combine all these words, we will get one statement. In turn, we can call it as one block. The one block is responsible to do one action on the machine tool, as I said just now. Okay. So now this tells us one block. Then if we combine the number of blocks together, so we will get one program. So as you can see here, So a program consists number of lines. In turn, we can call those as blocks. So which will be executed by the machine control unit. So one block of statement, this block of statement, or in turn we can call it as one command, will be read by the machine control unit. In turn, that machine control will convert that command into the machine readable form signal. So according to that, the machine is going to perform the work. So this program is responsible for all the operations to be performed to complete the component. This is called a program. So a program is written, a program consists number of operations. In turn, operation is nothing but one block is responsible to do one operation. Then blocks are formed with the help of words, then the words are formed with the characters. This is what the chronology of the structure of the CNC part program. Now let us see all the discussion with a figure. As you can see here, the structure of the part program. You can see program consists. This is start programming, end programming. In between that, we have number of blocks. You can see here, block 1, block 2, and any number of blocks we can insert. So that means a program consists number of blocks. Each block is responsible for one action on the machine, and this block is consists of sequence number and the number of words. If we combine number of words, we will get one block. As you can see here, sequence number is one word, G01 is number is one word, and X12 coordinate is one word, Y value, Z value, and all these are called words. Okay, S word, F word we have seen in the previous slide. So if we combine these words, so we will get one block. And if we combine blocks, we will get program that we can see in this figure. Then we see if this word, then how do you get this word? If you combine characters and the numerical values, characters are the address. Okay, if you combine these characters and the address along with the numerical value, so one word will be formed. So words are combined together to form the block. Then the blocks are combined together to get the program. This is what the exact structure of the CNC program. And let me move further to discuss the sequence. Sequence is also very, very important. In what sequence we need to arrange these words. So while arranging or while writing the block of statement, so we need to follow one order or one syntax to specify the words. The words must be specified in a certain order in a block of statement. So in a block of statement, sequence number will be the first word. Then the preparatory word is the next function. So as of now, you will try to remember that the preparatory functions are the functions which are responsible for the movements of the tool. Apart from any of the operation related to the machine. So the preparatory function is specifically to control the movements of the tool. And similarly, you have the coordinate functions. So sequence number, then the preparatory function, then we have the destination coordinates of the tool, X, Y, Z coordinates, X, Y, Z functions are used to specify the coordinates of the tool, as you can see here. So X, Y, Z coordinates are followed by the preparatory function. Then we have the center of the circle. Suppose if your tool is moving in a circular path, in that case we need to specify the center of the tool. So we also need to require to specify the center coordinates of the tool. If our tool is moving in a circular path, in that case we are going to use IJK words or the functions or the codes. Then this center must be followed. The center coordinate values must be followed by feed rate. So feed function, then the feed function should be followed by the spindle function, then it should be followed by the tool. Okay, then we have the miscellaneous function. So miscellaneous function means other than the movements of the tool, we have the functions like the when to start the program, when to stop the program, whether the tool needs to rotate in clockwise, spindle needs to rotate in clockwise or anti-clockwise direction. All these uh, these are signified, are indicated by the miscellaneous function or the other function. So the preparatory functions are responsible for the movements of the tool, specifically for the movements of the tool, and the miscellaneous functions are responsible for the other than the movements of the tool. So just like the mission control functions, when to start coolant, whether to use coolant or whether not to use coolant, all these are indicated by M functions or the M codes or the miscellaneous functions. So this is exactly the syntax of one block. The words must be arranged in this order. The words of the block are the sequence. So all these words must be followed one sequence while writing the part program of the block. So this signifies one block in which sequence number, preparatory function, then coordinate values of the tool, then the coordinate values of the center of the tool, then the feed rates, speed, tool, and the other functions other than the preparatory functions, means movements of the tool. This structure we need to follow while writing the part program. As I said just now, sequence number is as n word, which is going to tell us the address of one block or the name of one block. So n is the number, n is the word, n is the alphabet used to specify the sequence number of a block, used to identity of the block, used to specify the identity of the block. So as I said, just you consider this. This is one block, NC block, N20, G01, X20, 0.5. Like this, we have one block of statement here. So in which N20 is going to specify the address of this block. And it is not going to specify the order of execution. It is going to specify only the address of this block or address of this statement. Okay. And as you can see, this is regarding the uh, sequence number. Then we have the coordinate functions. As I said just now, the X, Y, Z coordinates, the tool locations, the location of the tools, or the address of the tool should be specified with the X, Y, Z coordinates. And the IJK will also be used to specify the coordinates. And U, V, W is also sometimes used to specify the coordinates. So this is what the coordinate function XYZ, UVW, IJK are the coordinate functions used to specify the coordinates of the tooltip. Coordinates of the tooltip. Then we have the spindle functions. Means as we have seen in our block, previous block, and that block also you can see here. So this spindle function, S function followed by a number specifies that the spindle is going to rotate that much speed. So we are performing one operation here. Assume that we are performing turning operation. In that turning operation, the spindle is going to rotate with 1000 RPM here. So always this spindle unit is S function unit is RPM, revolutions per minute. Okay. S word, which signifies the spindle speed of 1000, as I said just now, this is always in RPM, revolutions per minute. Then let me move further to discuss what is feed function. In the previous slide, I said with you, so for each operation, so the feed may be different. If it is a finish cut, the feed of the finish cut is different and the feed of the rough cut is different. So according to that, in each block of statement, we need to specify the feed if you want to change as per our requirement. and this unit also varies from machine to machine. If it is a milling machine, the unit of the feed is per minute, not for the revolution. Okay, so there is no, I mean, the workpiece is not at all going to rotate in this case, in the case of milling operation. Okay, so the feed is specified per minute. So how much distance our tool is moving per 1 minute will specifies the feed function in the case of milling machine. Whereas in the case of turning machine, the feed is per revolution. How much distance our tool is advancing for one revolution. That is in the case of turning machine. This is called the feed, and feed in the case of turning machine, feed in the case of milling machine. Then it is the unit of feed rate has to be defined at the beginning of the problem itself. Of course, on which machine we are performing the work and what tool we are using, and this whether to specify according to the type of machine, we are going to specify the unit of the tool, whether we are going to use per minute or per revolution in the program starting itself. So we will discuss this function in detail in the coming sessions. What are the functions required to specify the units? Those are called the preparatory functions, which are specifically related to the control of the tool. That we will discuss different types of preparatory functions or the G codes in the coming slides or in the coming sessions. Then you consider one block of statement here. Now you can see in this case F200 is the feed function and 200 signifies the per minute. So our tool is going to advance or move a distance of 200 millimeters per minute. So in turn, you can call it as a milling machine. In the case of milling machine only, we are going to specify the feed unit as per minute. In the case of turning machine, we are going to specify feed as per revolution. By looking into this word, we can tell what type of machine, on which type of machine we are working. This is what the meaning of the feed as well as the unit of the feed and about the feed function. Then we have the tool selection. Now you can see here tool selection. I mean, what type of tool we need to use. Example, you take this block. I mean, this tool selection is applicable only for the machines which are using automatic tool changer or the tool turret. In the case of NC machine, which are incorporated, which are attached to the tool turret or the automatic tool changer, automatically if you specify T word, so the machine automatically will reach that point. That means ATC will reach that point and pick up that tool which is used to perform the operation. So that this tool word is used for the machines which are incorporated or which are attached with the tool turret or with the automatic tool changer. That means this is an automatic activity which needs to be changed automatically. So this word is used to change the tool and pick up the tool. Or the address specified T03 means, so 03 tool will be used and picked up by the automatic tool changer or the tool turret. Okay, and we have other functions, miscellaneous functions. As I said just now, we have miscellaneous functions also. These are used to instruct the machine other than the movements of the tool. So the movements of the tool specifies the in the case of preparatory functions that we will discuss in the coming slides. In the case of miscellaneous functions are specifically used to control the machine, like coolant on, coolant off, whether to rotate the spindle in clockwise direction or anti-clockwise direction. So these miscellaneous functions are specifically used for that. So now you can see here M03. M03 indicates it is a miscellaneous function which is specific to control the machine operations, like to rotate the spindle in clockwise direction. So this signifies that mission spindle is going to rotate in clockwise direction. That means this word is going to instruct the machine to rotate the spindle in clockwise direction. This is what the meaning of the miscellaneous function. So there are different miscellaneous codes. Some of them are listed here. As you can see, if you want to stop the program, M00 is used in the block. And spindle, if you want to rotate the spindle in clockwise direction, we can use M03. Just now I said with you in the previous slide. Then M04 is used for spindle rotation in a counterclockwise direction. M03 is for clockwise, M04 is for counterclockwise. Then to stop the spindle, we can use M05. Because sometimes in between the program also, in between the operations also, if we want to stop the spindle, so which can be instructed by using one function or code that is called M05. Then if you want to change the tool, you can instruct the machine to M06. Then coolant on, coolant off, then clamping and unclamping using M10 and M11. Then if you want to stop the program, you are going to use M30. M30 is a code or a function, miscellaneous function, use it to stop the program. This is what end the program. We are ending the program, then we are stopping the program. These are different. So in the next class, we will discuss the preparatory functions in which we will see the interpolation, linear interpolation, then circular interpolation, then what exactly the tool compensation. Along with these important preparatory functions, we will discuss some more preparatory functions in the next slide or next session. Then we will also discuss the programming formats. So there are different programming formats like the fixed block format, tab sequential format, word address format. We will discuss these types of programming formats in the next session. Then we also discuss the canned cycles, repetitive cycles. Suppose if you want to produce a hole at different locations, we can reuse that program, written code repetitively to produce. So those are called the cycles. So we will discuss the cycles also in the coming session. So let us see what we are discussed as of now. We are discussed the miscellaneous functions, then we are discussed the tool selection T function, then feed function, then spindle speed function, coordinate functions we have seen. Then we are discussed the importance of sequence number. Then we have seen the structure of part program. Then the structure in consists the block, program, word, and character. We have defined what exactly the character, word, block, and program. Then we are also defined the program, what exactly the program and what it consists, what information the program is going to consist, that we are discussed in this session. Then we are also discussed what exactly the fixed zero and floating zero. While writing the program, we can shift the origin point. If you fix at one location, that is called fixed point zero. Conveniently, if you change the location as per the programmer's convenience, that is called floating 0 point. Then we are also discussed the coordinate referencing methods absolute and incremental positioning in this session. So that's all from my side in this session. We will see the contents in the last session, in the next session. Thank you. Thank you.